The first step is to create the drawers. Let me keep this away first. Okay, right. First step is to create the drawers. In this chapter, we call it force and motion 2. This is Form 5. Form 4, there's another chapter called Force and Motion 1. Right, but it's fine. We're gonna learn that Form 4 after this chapter, maybe next week or the week after. Okay. So first step, we have to create drawers. So I created 4 drawers. Right. I've created 4 drawers, and these 4 drawers are, for this chapter, is the same as the sub drawers or sub chapter of this chapter. If you see your textbook, the SPM textbook, these are the 4 sub chapters: resultant force, resolution force, and force in equivalent, and elasticity. Right. So like I say, we need to remember these 4 drawers in sequence. How do we remember these 4 drawers in sequence? I created a story. And this story usually is something not doesn't make sense in the real world, but it's just to create an emotions that can help you to remember this in sequence, right? So let's see whether we can remember this by just remembering this very short and funny story. I get SPM result. My 2026, you know, the every year you have a yearly resolutions. So your 2026 resolutions is equal to 2025 to become plastic man or plastic woman. For singling case, is plastic woman. For the rest, is plastic man, right? So why do I use this story? Because number one, when you get SPM result, that is the resultant force. To help you to remember, the first drawer name is resultant force. Then the second is resolution forces, right? So resolution forces. Equilibrium, equal. I hope equal is easy for you to link it with equilibrium, right? Then you have elasticity, which is plastic. Okay, usually we relate plastic with elasticity, right? So this story is what I've created. All right. If you think that you have a better story, by all means, do it by create by yourself. But for this case, now let's follow this story. And the purpose of this story, like I say, is to help you to remember this drawer in sequence, the name of the drawer in sequence, right? So I hope that you can jot down this story. You can jot down this story because this is the anchoring point. The anchoring point of the brain. I'm using this a lot later to anchor your brain. Like I explained to you just now, the flying brain and the anchor brain problem. All right, I'm going to help you not to have your flying brain problem affecting your study for these 2 hours. Right. So I hope that you're going to write it down and then remember this. It's a very short story. And this story is easy to remember. You get your result. It can be SPM, or for Aiden, you can be your social science results or whatever big exam result that can trigger emotions. You get your exam result, then your 2026 resolutions is equal to last year. This year resolution is equal to last year. To become plastic man or to become plastic woman. Okay. So that's step number 1. Let's go to step number 2. What time do we start here? Okay, let's see. Now it's 6:13 a.m. We started at 6:13 a.m. Let's see what time do we stop. Okay. Step 2. Step 2 is to read keynotes. Step 2 is to read keynotes. Like I say, I am not your typical tuition class teacher where I'm going to speak 90% of the time. No, because this is another way of studying that I'm trying to teach you. In fact, you'll be reading 70% of the time or 60% of the time. So please expect that, right? Expect that you're going to be reading quite a lot. And don't worry, I'm not going to ask you to read it out loud. You just read it by yourself. And I'm going to set some timer. And that timer, if it will help you to guide you when to read and what to read at what time. Okay, so let's go to step number 2. Step number 2 is to read keynotes. You can read this and you can ignore the part that is in the bracket for now. So every drawer, there's something in the bracket. You can ignore that for now. You can read from here to here, and if you realize it is being designed in a way that's similar to the 4 drawers: resultant force, resolution forces, equilibrium forces, elasticity. Okay, let's start to read from here, resultant until parallel. I'll give you 2 minutes to read. Let's start now. 2 minutes. Okay, read from resultant until parallel. Don't worry if you don't understand. Okay, 1 more minute. Thirty more seconds. Ten more seconds. Right. Okay. In case anyone is worried and anxious that she or he has no idea what she has been reading, that is fine. And that is normal. Because the keynotes is not designed for you to understand everything. Right? The keynotes is a reference. Later you're going to read these keynotes many times. And you know why. Right. So how do you read? How do you? What is the goal of reading these keynotes? Step 2, when you do not understand fully, the key is for you to know that there are 4 drawers over here, and for you to know that there are some key words that's related to each drawer. Right. For resultant force, you have the definitions. Right. I think this definition, when you read this, maybe you roughly understand what it's talking about. Roughly, right? It's talking about the vector of 2 or more forces acting on an object. Right. For those who understand fully, congratulations. For those who doesn't understand fully, it's fine. This is normal. Then there is something related to same direction, opposite direction, perpendicular or non-perpendicular. What exactly is this? Don't worry. You just need to know there is something related to the directions that's related to this drawer number 1, which is resultant force, right? Which is related to your SPM result, okay, in the story. Resultant force is SPM result. Then there is something related to this Newton's second law, F equivalent to ma, right? And there's also something related to the stationary constant velocity, constant acceleration. If you don't understand fully, don't worry, that's normal. If you understand fully, congratulations, continue, right? Then there's something related to the free body, right? This is about resultant force, which is drawer number 1, which is when you get your SPM result. Okay, relate to this story, SPM result. Okay. Number 2 is resolution forces. Resolution forces, also there is a definitions. Okay, splitting a single forces into two perpendicular component. Like I say, if you don't understand this sentence, it's fine. You're gonna know it later. You just need to know that there is a definition for it, and also there is this very weird formula for it. This fx and fy, right? So there are two perpendicular components. One is fx, number 1, perpendicular. Number 2, perpendicular is fy. And this is how you're going to calculate them. And that's it. So there are only 2 points that you need to know for drawer number 2. Like I say, if you know it perfectly, what is this 2 points about? Congratulations. If you don't, you are normal. You are like any other student. Okay? But we are trying to, we will definitely know what is this after you finish the step number 10. Now we are still in step number 2. So don't worry. Be patient. And that is about your to this year resolutions, right? Remember this year resolutions. So resolution of forces. Forces in equilibrium. Also, there is a definition, and the equilibrium, the name itself gives you an idea what we are going to learn. It's talking about the state of equilibrium, static, not movement. Then there is this triangle forces. Triangle forces is a method, okay, for you to define this equilibrium, and that's it. Okay, and that's it. Okay, and that is equal. So your this year resolution is equal to last year resolutions. Last drawer, elasticity. This is the plastic woman or plastic man. Okay, and this you have a bit more information that you need to know that's related to this elasticity, the plastic woman. So you have the Hooke's law. You have the how the factor of affecting the spring constant. Or so now that this, you know that there's something that you have to learn related to spring, right? And then there is this elastic limit. You know that spring, you cannot pull it unlimited. There's this limit that they can have this elastic limit. And what is this limit? Right, this is the limit. Right, this is the limit. If you don't understand now fully, it's fine. Again, don't worry, be patient. You're gonna know this as we go into the further steps. Now we are only in step number 2. Okay, we are only in step number 2, and you are just 10 minutes away from the starting time. So 10 minutes, and if you don't understand fully, that is fine. Okay, so you have something that you have to learn about the potential energy, and then the series and parallels that you have to learn. What is this? It's fine if you don't understand. So that is the plastic woman. So that is I get SPM result, and my this year resolution is equal to last year resolution to become plastic woman, right? Your resolution for this year and last year is the same. You want to become plastic woman, and that will help you to remember this drawer in sequence. I hope now you have some idea what are how many drawers. Number 1, okay, number 1, you need to know how many drawers. There are 4 drawers, and what are the drawers name, right? For those who can remember the drawer's name by now, congratulations. Okay. For those who cannot remember, I hope that you are able to at least remember 1 or 2. And by now, you should be able to be comfortable in remembering 1 or 2. And later, you're going to remember it by heart. Okay. So that is step number 2. We only took 10 minutes to complete step number 1 and step number 2. The following step is a bit heavy in terms of reading. So I need you to be with me, right? Focus and give me another maybe 2 hours, right? 2 hours is not a very long time, but I need your attention for these 2 hours, and let's see whether these 2 hours I'm able to, or you are able to teach yourself this chapter. Okay. Why do I say you are able to teach yourself? Because most of the work is done by you, not me. I'm not your typical tuition teacher, right? I'm just helping you or guiding you on these steps of the learning method, the brain drawer learning method. So let's do this. How we are going to do this is I'm going to pick a paragraph, okay, like this, a small paragraph that you're going to read. I'm going to give you maybe 1 minute to read, right? So now you know that this part that you are reading is drawer number 1, resultant force. So drawer number 1, okay? What I'm going to do, I'm going to do like this, okay? Just so you have 2 windows over here. The window on the step number 3 on your left, and on your right is the step number 2, keynotes. Okay, so you just need to focus here. In fact, you only just need to focus this small part. The number 2, number 3, number 4 in this drawer number 1, don't need to focus, right? Because this part is explaining the definition, right? This part is explaining the definitions. So without waiting further, let's try. I'm going to give you 1 minute. You read from drawer 1 until the directions, and then you try to link it with this point number 1 in this drawer 1, right? You try to link it, right? I hope it is understand. Okay, I hope you understand the steps, what you need to do now, right? Just follow the steps, and I'm sure that you're going to learn this in no time. Learn the entire chapter, not only this small part. In 1 minute, let's read from the drawer number 1 until direction. Okay, is 1 minute enough, or you need more time? If you need more time, let me know so that we can adjust accordingly. If not, we are going to go into this pace. Okay, no one raised their hand, so I assume this is more than enough. Right? So let me. Okay. So how does brain drawer how the brain drawer works is we build each and every information or knowledge slowly, right? You see, the first step when you read this, for those who did not fully understand it, you already have some idea that in the first drawer, resultant force, there's definition that you need to remember or you need to understand, right? A single force that represents the vector sum of 2 or more forces acting on an object. Now, the next step, which is step number 3, this part is elaborating more on what you have read just now, this single line, right? So this is how step 3 is going to, step 3 works. The next paragraph is going to be related to point number 2. Okay, so I hope you are able to follow me on this part. So we are going to build this slowly, like a Lego. I'm going to build this slowly with you like a Lego, right? So this is skill number 1. Remember the skill number 1, student A and student B, to build your knowledge base bigger and bigger and bigger and bigger. So this is what we are trying to do. We're trying to build your knowledge base for this chapter, force and motion, bigger and bigger and bigger and bigger, right? That's point number 1. Later, we're going to continue with point number 2, how to recall this faster and how to identify new information and store it into the right right slot, right drawer. Okay. Now, I'm going to give you also 1 minute. We'll do the same exercise, and you read this, and that's point number 2. Let's start now. Right, so this is the second round. I hope 1 minute is good enough. It's not too short. For those who finish reading it, you can keep reading it to use up, to fully utilize your 1 minute, okay? So you see, now this is about the directions. And it's related to point number 2 here. So now I hope, and I know that you feel that you are understanding this sentence or this point more, a bit more than 10 minutes ago, right? So this is step number 3. Imagine we are only in step number 3 now. What if you are now in step number 9? Your understanding is going to go deeper and more and more and more. So we are building this knowledge base. And now at the same time, because we have already created the drawers, we are putting these informations or knowledge, the new knowledge or information that you read here, and put it into the right drawer, the first drawer, which is the resultant force, right? Put it inside in the story inside the right drawer. So that is also skill number 3. All right. So we are trying to build this 1, 2, 3 skill for you in this chapter. Okay. Again, if you do not fully understand everything in this 1 minute of reading, it's fine. As long as you understand a bit more than you understood by reading this. And that is already an achievement. And that is what we are trying to achieve. Right? Now, let's continue. Let's make it like this, okay? Number 3, let's do the same drill. 1 minute. Let's do that. If you finish reading it, read again and again, okay? Yeah, because not everyone is reading at the same pace. Some are fast reader, some are a bit slower. It's fine. So this point number 3 is related to point number 3 and point number 4 over here. Newton's second law and free body diagram, right? Free body diagram and Newton's second law. And now I'm sure you have more knowledge or informations related to what is this stationary constant velocity and constant acceleration. Right, constant is uniform, it's the same thing. Right, and that is being explained over here in this table. And free body diagram, what is this? Right, similar, it's explaining almost the same thing. So there's no new information being discovered over here. Newton's second law. This is Newton's second law. So now you know m is mass, a is acceleration. Now, do you realize that you have new information you discover over here? And this is the skill number 3. Once you identify new information, what do you need to do? You need to know exactly where to store it. And where do you store it? You store it inside drawer number 1, which is called resultant force. Now you have this F equivalent to ma, which is mass times acceleration. It's a new information for you because you do not know what is m, what is a before reading this paragraph. And this new information, you need to intentionally pick it up and put it inside your drawer number 1. So your drawer number 1 is getting more and more information and knowledge as you read more, as you go further into the steps. Now you are only in step number 3, right? I think let's continue. Drawer number 2. Drawer number 2 is the New Year resolution, right? This year resolution equal to next year, last year resolution. Equal is equilibrium. So you know even the drawer number 3 what does it call? Force in equilibrium, right? But let's forget about draw number 3 now. Let's focus on draw number 2. Now, draw number 2 is resolution of forces. So, as you know, I think you have done this drill already in draw number 1. We are going to focus here. Draw number 1 and draw number 3 and draw number 4. Don't worry about those texts now. Just focus on these 3 lines. Resolution of forces. Now, we will read for 1 minute for here. Okay, let's do this. Let's do it again, the same drill. 1 minute. Ten more seconds. Right. Okay. That is drawer number 2, the first part. The first part. All right. In fact, this one is already touching the second point here. Okay. So I hope by now you discover or you identify new information that is coming out from here by reading this against this information that you had maybe 20 minutes ago. And this new information, where do you store it? You store it inside your drawer number 2, which is called resolution of forces, right? Which is the year to this year resolution, okay, in the story. Okay, and this part, now hopefully you have more information and understanding what exactly is this. If not, you are still fine. Don't worry. We are still in step 3, right? We are still in step 3. Okay, this is a bit of a calculations, but you can read this in 1 minute. Fifteen more seconds. All right. That is drawer number 2. Right. Isn't that easy? You already completed 50% of the entire chapter for step 3. Right? We only have 2 more sub chapter remaining. Okay. If you feel a bit tired, or you have to tell me, right? Because not everyone is used to reading so much of text at one go. Okay, I'll continue because I think this is still fine for us to continue. Let's do the next drawer. So the next drawer, always keep reminding yourself which part of this drawer it is in the story. Equilibrium is the equal. The last year, this year and the last year is equal. The resolution is equal. right? I'll be keep repeating. I'll be repeating this quite a lot on the drawer because that is very important. Because that is the anchoring point. Remember the anchor brain compared to the flying brain. We have to have something to anchor. So if you do not remember the name of the drawer, then there's no anchoring point for you. So that is our anchoring point. That is our focus point. Okay. So let's read these definitions until this picture over here for 1 minute. And that is, now we have already moved to drawer number 3. Forces in equilibrium. Let's start now. Ten more seconds. Okay, that's it for drawer number 3 for this part. Let's complete this part for drawer number 3. Okay, let's start now. Same drill. Same technique, same method. Twenty seconds. Okay, that is drawer number 3. We have done. Now moving into drawer number 4. Drawer number 4. Okay, by the end of these steps, I'm going to ask someone a small question. Okay, so be ready. Let's start now. Drawer number 4. Ten more seconds. Okay, let's do spring constant until potential energy. Spring constant until potential energy. Let's start now. I'm going to ask a quiz later, okay? It's a very easy questions. All right. This very small part, okay, I intentionally leave it over here. So for those who wants to read it again, you can read it. Let's go. I'll give it 1 minute also for this part, for the last drawer. Fifteen seconds. I'm going to ask a question. Be on your toe. All right. Now, before we move on to step number 4, which is read FAQ. FAQ is frequent asked question, but let's forget about that for now. Can somebody tell me what is the story that helped you to remember the name of the drawer? Anyone volunteer before I pick and choose? The story. Remember the story to help you to remember the drawer? The story? No one? Then I'll pick. Aiden. Aiden.
Yes, I'm here. Yeah,
Yes. Can you just tell me the story, the short story?
my story. I created was like my social results, weekly resolution, my grade, and I was like, and I like frequently like elastic, which is like frequently changed, and like I don't know how to like
Okay,
elastic.
your voice is a bit breaking. I hear the resolution. I hear the I did not hear the plastic woman. Right. So anyone want to give a try? The story?
Sorry, my mic might be a little broken. Might be a little
A-
broken. Sorry.
Aiden, your voice is breaking. I cannot hear very clearly. Maybe you can type out. Maybe you can type out in the chat the story while we are waiting for. While I ask some. Do you think some? Do you remember the story? Uh, Yenda, do you remember the story?
Um, I get SPM result. My
Yes.
2026 resolution is equal to 2025 to become plastic woman.
Excellent. Excellent. And this, can you tell me the name of the drawer for the 4 drawers? What is drawer number 1?
Resolution force.
Resolution force is number 2. What's number 1?
Um,
SPM result. SPM
Resultant
result.
force.
Excellent. Okay. Number 2 is resolution force, which is the number 3.
Force equilibrium.
Yes, the equal. Number 4.
Elasticity.
Yes. Yes. Exactly. So Yenta, you are following well on this brain drawer method to at least to remember there are 4 drawers, and also to to remember the name of the 4 drawers. Right? So Aiden and Jim Sam and Xingling, I hope you also remember the drawer. That's why it's good for you to write down the story. Where is the story? Yes, this one. Write down this, and this will help you to remember the name of the drawer. Right. And so far, we are all focusing on these 4 drawers. Step 2 is about these 4 drawers. Step 3 is also about that 4 drawer, the one that you read. Every 1 minute, you read some parts. Right? Now, by now, I hope that my student, which is this group, when you read this again, you understand a bit more than when you read this the first time. When you read this the first time, we started at 6:13. Now it's 6:51. Is maybe half an hour ago. When you read this the first time, and if you try to read this again, I think you will feel that you understand it more. Right? Can you read this again? Let me give you 1 minute to read this. From resultant force until series and parallel. Twenty seconds. Read this. Okay. If you, after reading this, if you feel that you understand more compared to the first time when you read this, and that is the feeling that I want you to have, and that is the good, right? Because we are still in step number 3. As we go by to step number 4, number 5, number 6, and I will ask you to read this again. This feeling is going to get stronger and stronger and stronger. That means you are going to understand this chapter more and more and more, right? That is what we are trying to achieve in these 2 hours. Okay? Can I have a show of hand that you are still with me? Because this class is too quiet. Yes. Yenda, I'm sure you are still with me. Right. And I see from Xingling, I see from Aiden, and I see from Jingsan. Jingsan, your mic is not working, I know. And Aiden also, I think your mic is also not too well, or your connection is not too well, because it was breaking just now, right? So I hope that by now you remember this. No problem, Aiden. You remember this story, right? That's why when I started the class, I want you to write it down if you can. You have to remember this story, because this story is the anchoring point of the entire brain draw. Right? When you have this story, you can remember these 4 drawers, the name. When you can remember these 4 drawers, then I'm sure when I talk about resultant force, by now, you already have some idea what is this resultant force. It's about the directions. It's about Newton's second law. It's about free body diagram. Maybe you do not fully understand what are all this in detail. That is fine. You just need to know there's something, the key message or the keywords that is related to this drawer number 1. Then repeat the same process. Drawer number 2 is about something related to force X and force Y. And there is this funny formula, right? Then you have draw number 3. It's about equilibrium. The name itself is equal. So something is equal. What is equal? Then elasticity, the plastic women or plastic man, right? So there's Hooke laws in it. There is factor that's affecting the constant of the spring, and there's this elastic limit and potential energy, and there's this series and parallel, which you have read a while ago, right? You might not fully understand now. It's fine. We are just 30 minutes into our class, right? In 30 minutes, you already know. We are building that drawer for you. I think that drawer is already built. The framework is already built. Now we are trying to fill in the items inside the drawers. So the drawer is not empty. Okay? I hope this is clear. Now let's go to the next step, which is step number 4. Step number 4, we have, okay, after step number 4, which is I think about another 15, 20 minutes, then we will go for a short break, for water break and for toilet break. Okay, so in maximum 20 minutes, you're gonna have that break. So let me continue on step number 4. We have 8 frequent asked questions. So what are you gonna do is you read this question, then you ask yourself, which drawer is this? Is it drawer number 1, number 2, number 3, or number 4? Right, so let's do this quickly together. What is a resultant force and how is it determined? Do you think it's drawer 1, 2, or 3, or 4? Can anyone give a guess? You can type or you can tell me from the mic. 1, 2, 3, or 4. Anyone? What is a resultant force and how is it determined? Drawer, which drawer? 1, 2, 3, or 4? Hurry up.
One.
1, excellent. All right, it's easy, right?
Wait,
Because
is
it's talking about
my
resultant
mic
force.
working?
Yes, your mic is working now.
my-
Good.
Okay,
Yes.
okay, that's good. Okay, thank you.
Yes, your mic was working just now, but just it was breaking. Yes, dim sum is 1. Yes, it's very clear. Right, resultant force. And usually this give you a small tips. My FAQ 1 to 8, you're gonna see 8 questions. They are all in sequence as well. Very rarely I will change it. So obviously 1 is or drawer number 1. Then you have question number 2. Question number 2 most likely is also drawer number 1, or maybe drawer number 2. It's really depending. Okay, so we can go to drawer number 2, question number 2, and quickly see whether it's drawer number 1 or number 2. Why is it important to understand resultant force, resolution forces, and forces in equilibrium? This is not drawer number 1. This is a combination of drawer number 1, 2, and 3, right? Because it's talking about resultant force, resolution force, and equilibrium, right? Now, let's do this in 1 minute. Let's read this. I know it's a bit scary to read the formula, but give it a try. In 1 minute, let's read this. How do you read this? Okay, let me tell you. Like I say, you read the questions. You ask yourself which drawer, 1, 2, 3, or 4. Now we have determined that it is drawer number 1. Okay, then focus on drawer number 1. Then read from this a resultant force until these forces. Try to understand it. If you understand something newer than what you understood before, in step 3 and step 2, there's no such information. That means what? That means there's a new information that you need to intentionally pick up and put it inside your drawer number 1. Okay? Okay, let's do that. 1, 2, 3, start now. Okay, so this question is about the directions. So it's here. It's about these 2 points, definition and directions. Right, so this part is talking about the vector sum of the 2 or more forces acting on an object. This is the definitions. Then you have the directions. So the resultant forces you can determine using 4 type of directions: same directions, opposite directions, perpendicular, or non-perpendicular, which is point number 2. Now you have new informations, and the new information is the formula, right? If you do not remember this formula, it's fine. Don't worry. You just need to know there's new information that you need to store inside this drawer. We are not here to become genius in 1 day or in 30 minutes. For this case, it's 30 minutes. We just started 30 minutes ago. We are building this together slowly, right? We are building this together slowly. So that is the point. That is the point. Don't set the wrong expectation on yourself on something that is impossible to happen, right? Building it slowly. Okay, so same thing. Let's do question number 2. First, read the question. Ask yourself which drawer. You need to know which drawer first. Even if you get the wrong answer, if let's say you answer this drawer number 4, which is totally not correct, it's fine. When you read the answer, then you realize that it is not drawer number 4. Then you have to change your answer to the right answer. For this case, it's drawer number 1, 2, and 3. When you read this, if there is new information that you read from this answer, intentionally put it inside your drawer. Right? Let's do this. 1 minute. Let's start now. Okay, if you finish reading and you want to read the question number 1 again, you have this part to read. Okay, 2 more seconds. Done. I hope everyone is following, all right? Okay, let's do this. Also 1 minute. If you finish reading and you want to read again the one that you read just now, I intentionally leave it on top. Let's start now. This is drawer number 2, resolution of forces. Fifteen more seconds. Okay. I think you should realize by now, I mentioned this like 3 times. I'm not your normal tuition teacher that I'm going to explain to you each and every concept. Because I'm not teaching you science or physics. I'm teaching you the learning method, right? So let's set the right expectations. Now, let's continue on these 2 questions and start now. This is drawer number 3 and drawer number 4, because it's talking about equilibrium and elasticity. 10 more seconds. Done. Okay, let's do this one, these two. Let's do these two. Let's start now. Drawer number 4 and drawer number 4. Twenty seconds. All right. Let's do the last one before we go for a break. Okay, this one for those who finish reading it by 1 minute, and you can read the one above the previous one, the previous question above. So this is about drawer number 4, potential energy. So there are two equations. Twenty seconds. Okay. Next, we'll go to step number 5 after the break. Okay, let's start 5 minutes break. You can go for your water break or toilet break. We'll come back after 5 minutes. Thank you. I'm back. If anyone have any question, you can type or you can ask. I hope everyone is following. Okay, 1 more minute and 30 seconds. Get ready. I'm going to pick someone to tell me the story. The story of the plastic woman. So get ready if you are not ready. One more minute before I ask the story. All right. Anyone want to volunteer to tell me the story? Hurry up, hurry up. Anyone? Yin Da, Jing Sam, Xing Ling, Aiden. No one, then I'll pick and choose. Just now was Yin Da who explained the story. Let's try Jing Sam. Jing Sam, can you tell me the story? Or Aiden, whoever? Or even Xing Ling? Xing Ling, I know she's very shy. Okay, type. Right. Xing Ling, you can also type if you want. Xing Ling is the only girl here, so we'll take care of her, don't worry. Okay, Jing Sam is typing, so let's wait for a while. Yes. So Jing Sam type, I get SPM result. My 2026 resolution is equal to 2025 to become plastic woman. Yes, that is the story. Once you remember this story, you will be able to remember the name of the drawers. There are 4 drawers: resultant force, resolution forces, equilibrium, and elasticity. Resultant force means the SPM result. You get your SPM result, or you get your A-level result. Then your this year resolution is the same, equal to last year resolutions. So you have drawer number 2 and drawer number 3 in that sentence. Resolution forces and forces in equilibrium. to become what? To become a plastic woman or plastic man, right? That is elasticity, right? So that will help you to remember the drawers. Why this drawer is important? Because it is the anchoring point. If you realize step 1, step 2, step 3, and step 4, they are all related to the drawers. Yes, I saw Jing Sam typing the 4 drawers. Yes, exactly. I think Jing Sam, you get the idea. Yenta, definitely you got the idea. Aiden, this is your second class. I believe that also you understand this well. Xingling, I'm not too sure, but I think you're gonna I think you got it. All right. I hope you got it. Right. So this is the anchoring point. I'm trying to build this drawer for you, and that is your brain, to let your brain to anchor. Now, at least if anyone asks you today, what do you know about force and motions? To the very least, you know that you can tell him or her that is relevant, is linked to something related to resultant force and resolution forces, and something related to equilibrium and elasticity. Then from there, you can start to elaborate. Okay, what is the resultant force? You learn about the definition of the resultant force. Okay, the vector sum of two or more forces acting on an object. You can already explain that. Then you can talk about the top of wall, the opposite directions. Right? If the left side is stronger than the right side, obviously the force will go to the left. Right? The force will move to the left. Then same forces, obviously the same forces in the same direction, you will go to the same direction. Perpendicular, non-perpendicular. Right? So there are different ways of calculating the resultant forces. So these the things that you can explain. Then Newton's second law. Then the free body diagram. Then second drawer, you can tell this person who is asking you what is force and motion, what do you learn there. You can talk about resolution forces. You have to separate or split, they call it split into two single forces, which is the x axis and the y axis. And how do you make it to y and x? With this formula, F times cos theta, F times sine theta for y. Right, then equilibrium. So equilibrium, also there is information inside the equilibrium that you have already went through. And elasticity, right? Those are the Hooke's law, the constant factor affecting the spring constant, and such, right? So this is what we're trying to achieve here. And we only started at just now. What time did we start? 6:13. So it's only 1 hour. Usually, if you sit down and read your books for 1 hour, how much information or knowledge that you gain from that 1 hour? Maybe not too much, right? But now, by just following these steps, and we are doing it very slowly, by the way, and after 1 hour, you already have quite a good understanding. I will not say very detailed, but good understanding about what is this chapter about. There are 4 key drawers, 4 key points that you need to know. And each of the key points, you have smaller key points that you need to know inside that particular key point, which is the drawer. Right? Okay, let's not talk too much because, like I say, I'm not your typical tuition class teacher that I talk 90% of the time. Let's continue. I hope you get the feeling, you get what I'm trying to teach here, right? If not, continue on the step 5 until step 9. I hope then by then you can get the principle or the concept of this brain drawer, right? Let's do this. This is a bit long, okay? Same thing. How do you read this? When you read this title, you tell yourself, which drawer is this? Drawer number 1. Then focus here. drawer number 1. And then when you read this, as you read along, you ask yourself, which part in the drawer number 1 it is related to? Yeah, from the look of it, it looks like, the definition is there, which is number 1. And then the effect of motion, which is, I think, is the direction. Okay. And then the free body diagram, which is here. Okay. Which is the number 4. Right. So let's take 1 minute and read this. And I hope by reading this, now you're going to have better understanding. Start now. One minute is up. Okay. This is drawer number 2. Okay, let's do this. Let's do again from here to here. 1 minute also. Let's start it. So we'll complete drawer number 1. Ten more seconds. All right. So this is drawer number 1. Okay, before we go faster, let me set the right understanding of how, or right techniques. How do you work on step number 5? Step number 5 is you read and you ask yourself which drawer, and when you read the content, you intentionally pick up the new informations that you never know before step 4 or 5 or 3 or 2, and pick it up and store it in drawer number 1 inside your brain. Of course, you are not writing it down. If you are writing it down, it's even better. If not, then intentionally pick it up and put it into the drawer number 1. Right. There are 3 skills that a smart student or a version of yourself need to have to be an A version. And that 3 skill is you need to have a bigger knowledge. You need to have a fast recall speed from the knowledge base that you created. And then you need to be able to identify new information and store it inside your knowledge base in the right slot, in the right place, not just put it anywhere. Okay, so this is what we are trying to train you. You find new information over here, and then you slot it, or you place it, or you store it in the right drawer. Okay, and the right drawer is resultant force, drawer number 1 for this part. Now, let's do this very small, very short paragraph over here for 1 minute. This is drawer number 2. Let's start now. Okay, done. Okay, drawer number 3. Let's start now. Ten more seconds. All right, let's go to the last drawer. Okay, let's start now. Ten more seconds. Right, done. Now, if you read this again, let's quickly read this for 30 seconds. I'll give you 30 seconds. All right. You know what is the answer? What is the question I'm trying to ask you? Right. Do you feel that you are able to understand this step number 2 much better? Can I have a show of hand if those of you who have the same feeling? Jing Sam, yes. Xingling, excellent. 眼大，你还在吗？ Are you still there? 眼大, yes. Okay. So I see that Jing Sam reply and also Xingling reply quite instantly, and I believe that you have the same feeling. I know Aiden is having that because this is the second class. Yenta, I'm not sure you are still there, okay, but I hope you are because you are the number 1 student, the first one who explained to me the story, which is a very good start, right? No, now there's nothing changed here. I did not change anything over here. I did not type anything new. I did not change any wording over here. But what is changed? You are able to understand this much better than maybe one hour ago when we started this. What is changed? The only thing changed is you went through step 3 and 4 now, and you are able, even 5, okay? And you are able to gain more knowledge compared to 1 hour ago, right? That is the only thing changed. So now we are in step 5. We are going to step 6. Imagine how much more detail or how much more information that you can understand on regarding this chapter, when you're into step 6, 7, 8, and 9, there will be more to come. Okay? Why am I keep emphasizing on this? Because I want you to see the progress. When you see the progress and you have this positive progress, then obviously you are more motivated to continue on the next steps. Right? Now, let's go to the next steps. Step number 6. This very ugly picture that I draw, okay, it's very clear that I'm not an artist because this is what I draw. So what I did, I create stories. Remember, I told you emotion plus information equivalent to long-term memory, right? So this is the silly story or funny story that is giving you some emotions, right? Whether it's positive or funny or negative emotion, doesn't matter, as long as there's emotions, so that it will help you to remember the story easier and link this story to the informations inside your drawer. Right. Let me tell you the story and let's see whether this makes sense. And this story is in this bracket. Now this bracket, the information inside this bracket is important. Right? So every bracket, every drawer, there is a bracket. And this bracket is related to the story. Right? If you could, I would really appreciate that you try to draw the story as I explained, right? In my class, I realized that if the student take the initiative to write down these two things, right? Write down this story and also draw this very ugly picture, he or she will be able to get the full potential of this 2 hours faster. Yeah, you only need to do two things, right? Other than reading, of course. Write down this story somewhere and also draw this picture as I explain to you what is this picture about. Right. I'll leave it to you, but I'll continue. Now, what is this story? I created GPS direction, new mommy, okay, I spell it MAMMY, with free body, right? So this, if you see, there are this in this picture, just focus on this quadrant because this is resultant force, right? So there are 4 drawers: resultant force, resolution force, equilibrium, elasticity. So now just focus on this number 1. And this number 1 is GPS directions and new mummy with free body, right? So let me explain. What is this GPS directions? When you move from here to here is the same direction. And then when you reach to these T junctions, you move to this direction and your brother or your sister move to the other direction. So this is opposite direction. Then for yourself, let's say this is your path, you go up. You go straight. And your brother or your sister go on a perpendicular. This is perpendicular, this is non-perpendicular. Right. So I think you get the idea. What am I trying to illustrate over here? I'm trying to illustrate this part. Right. Same direction, opposite direction, perpendicular direction, non-perpendicular direction. Right. So same direction, opposite directions, perpendicular and non-perpendicular. So you just need to remember or draw out this very simple picture that can help you to remember some of the content inside drawer number 1. Okay. Second object over here is a new mummy. Okay. This is a new mummy, not the old mummy that you have today. A new mummy. Why is it new mummy? It's because Newton's second law. Newton, the new. I took the new. So Newton is representing in the new mummy. Why mummy? Because the formula is MA. Okay, MA. So it helps you to remember this, that, okay, there is something related to MA that I need to remember in this drawer. And I hope with this new mummy or Newton, it will help you to remember this easier, right? And then free body. This new mummy is very flexible. It's like having a free body, right? And this free body is to help you to remember there's something related to free body diagram in this drawer number 1. Obviously, I will not be able, or this drawing will not be able to represent everything inside this drawer number 1. Same goes to this step number 2. These keywords is also not representing everything in this chapter or in this subchapter, right? But we are trying to anchor something so that your brain can remember and understand much better, right? So that is resultant force, drawer number 1. So that is the story, the drawing and the story of drawer number 1. And that's it. Let's move on to drawer number 2. I hope this is clear. If not clear, please raise your hand and ask me. Okay? Drawer number 2 is resolution of forces. Right? Remember the story? Resolution. Right? We are here. Resolution. Okay? We got our SPM result, and now this year resolution. And this I created is a very simple story I created. Sine and cos. Sine is the y-axis force. Cos is the x-axis force. This you learn it in AdMaths. Right, I'm not sure whether you have learned it now, but you will learn it later. But for now, if you cannot relate, because you haven't learned this fundamental of maths equations, then just memorize. For now, just memorize, because it's too basic for me to explain. Right, Fy equivalent to F times sine theta. Right, Fy equivalent to F times sine theta. So sine is going up, vertical, cos is going horizontal. Okay, and that's x. And that's it. Okay, that is the story. Number 3, equilibrium. Equilibrium. Anyone put anything on the chat? No. Okay, good. So far so good. Equilibrium. So you have this Chris, Simon, Tony pulling you. Right. C equivalent to the cos. COS, this cos. Remember there's this triangle forces. They have to use cos, sine, and tangent to do the calculations. So Chris represents cos, Simon represents sine, Tony represents tangent, okay, and pulling you so that you are being pulled in 3 directions, and you are static because all 3 directions are exerting the same force. So there's no particular, you're not moving because you're in static. So this is equilibrium. So for Singling, you can imagine you have 3 boyfriends, right? Chris, Simon, and Tony. And they are pulling you in 3 directions. They want you to go with them to the place that they want you to go, right? And they are pulling you in 3 directions. For the boys, you can think of it, you have 3 girlfriends, right? But obviously the name doesn't suit. It's not appropriate. You can change C to a girl name, okay? S to Sarah, T to, I don't know, Tia, okay? Oh, right. So Christina, C to Christina, okay? That's pulling you. So you have 3 girlfriend or 3 boyfriend that is pulling you. They like you so much, they want you to go to the place that they want you to go to spend time with. All right. Elasticity. Elasticity is Captain Hook. Okay, this is a Captain Hook. I'm not sure whether you Captain Hook usually is the captain that is like a pirate, right? In the movie or in the series. Captain Hook, and this Captain Hook is very funny, right? They have two arms. Left arm is with gold, right arm is with silver. But left arm with the gold is shorter than the silver, right arm longer. I'll tell you why shorter and longer and why silver and gold a bit later. Okay, let me explain this. The leg also. So the leg over here also is a bit imbalanced. One is bigger and one is thick, right? One is bigger and one is thick. So you have imbalanced arm, you have imbalanced leg as well. Why is it gold and silver? Is because this factor that is affecting the spring constant is depending on the materials. So gold and silver represent the materials. Different materials, different spring factor that's affecting the spring constant. Then different length of the spring. So shorter gold and longer right arm silver. Right, short left, long right. Then diameter. So that is the leg. So you have a fatter left leg. So your diameter is bigger. Right. I hope you know what is diameter. Right. Diameter is like, is fatter. The diameter, the circle of the diameter is bigger. That means the circle is bigger. Right. Then thickness. So there's another leg that is thick. One is big, one is thick. It's two different things. Okay. And that is to help you to remember the factor that can affect the spring constant, right? Then you have series and parallel. Series and parallel, one is weak, one is strong. Then you have this formula. This formula, you just need to remember. It's easy to remember. Just F equivalent to Kx. And this one, potential energy, equivalent to 1 over Fx. Okay? So this drawing, if you can, you draw it. Or you can draw it later. It's up to you. But now, this is step 6. Finish. We finished step 6. Right? So we will go to step 7. Right? Step 6, if you already draw out your own drawing, put it right in front of you. So you have two things in front of you. The drawing and also this very short story. And that's it. To help you, this short story to help you to remember the drawer's name in sequence. Now, if we are going to step number 7. Okay, I hope everyone is following. I hope that everyone is following. Okay. Step number 7. We are almost there. You see, now it's 7. We only have 9. We only have 9 steps. 10 steps is to test you. Okay. We are almost there. And the next 3 steps is very easy. You don't need to read anymore. Maybe step 7 you have to read a bit more, but step 9, 8, and 9 is very relaxing. Okay, you don't need to read. It's just watch the video and listen to somebody explaining to you. Right. So just bear with me for another 10, 15 minutes. Right. Now, how do you do step number 7? You have 10 very short question and very short answer. That's why I call it quiz. So this question number 1, you have to read it out by yourself. And then the first thing, ask yourself, which drawer is this? Right. Which drawer is this? Then with this drawing in front of you, and with this keynotes in front of you that I'm showing you right now, before you read the answer, you form a very high level, a very rough answer that you could answer for these questions. This is to train the second skill, speed of recall. Remember, to become an A version of Xingling, to become an A version of Jingsam, to become an A version of Aiden and Yenta, you need to have the skill number 2, speed of recall. Right? By looking into this drawer, whether you are able to form the answer for this question. You do not need to have a very full sentence, just keywords. Keywords will do. Speed of recall is just about keywords. Okay, so let's try. I hope it's clear. I hope I'm not talking too much and it's getting too bored for you to follow me, right? So I'll repeat one more time. I'll repeat one more time before we start this. Read the question. Ask yourself which drawer is this? 1, 2, or 3, or 4. Then from this drawing that you draw, and maybe also from these keynotes, you form some answers about what is a resultant force, how does its magnitude determine an object state of motion, right? Form that first before you read the answer. Then you read the answer and tell yourself where is the new information. Okay, so let's do first part first. Read the question and ask yourself which drawer is this. Okay, clearly this is drawer number 1. Okay, drawer number 1. And by looking into this drawing and also with the help of these keynotes, are you able to answer what is a resultant force? Right, are you able to answer? Is something related to this vector sum of the 2 or more forces acting on an object? That is the definition of the resultant force. Vector sum of 2 or more objects acting. And how does its magnitude determine an object states of motions? Right? How does it magnitude determine? And this is talking about the directions, right? If the direction and also the value on the direction that is moving to, right? So once you have this answer on a very high level, then read the answer by yourself and see whether your answer is matching this answer. A resultant force is a single force that represents the vector sum of all forces acting on an object. If the resultant force is 0, the object remains at rest or move with constant velocity. If it is non-zero, the object accelerates in the direction of the resultant force, right? So this is touching even this part. Stationary, constant velocity, constant accelerations, right? So now I'm sure, I'm not expecting you to answer exactly like what this answer is providing, but if you are able to do that, excellent. You are congratulations. If not, there is new informations that you discover now, right? And intentionally put it inside your drawer number 1. Okay, so let's continue the same method for question number 2. I'll give you 30 seconds. I'll give you 1 minute. Let's do 1 minute. This is drawer number 2. Okay, we are running a bit late, so let's do a bit faster. Every minute we will do 2 questions. Same drill, same tactic, same method. Let's do question number 3 and number 4 now. Okay, question number 3 is drawer number 3, obviously. Question number 4 is drawer number 4, elasticity, with the captain hook. Okay, let's do 5 and 6. Total, we have 10 questions. Let's start now, 1 minute. $15 seconds. Done. 7 and 8. Let's start now. 7 is drawer number 1. 8 is drawer number 1 also, I think. $15 seconds. Okay, last one before we move to watch video. Video is very easy. Just watch. Okay, 2 more questions, please. Stay focused. Question number 9 is drawer number 4. Question number 10 is also drawer number 4. $15 minutes. 15 seconds. Sorry. Done. Okay. Let's watch the video. Let me just turn on the video. Can you hear the lady was speaking just now? Can anyone hear? Let's try again. Please, anyone can you show of a hand if you can hear? If everyone's here still awake? Okay, Aiden, you can hear. The rest can hear. Okay, good. I think the rest also can hear. Right. So how do you watch this? Not just watching it blindly, okay? You need to tell yourself which drawer is this related to. Okay, there are only 4 drawers. So relate this part, which part is talking about, is referring to which drawer. Okay, let's start now. It's only 7 minutes. Give me 7 minutes and let's start now. Obviously, this is drawer number 1, okay? Drawer 2. Drawer 3. All right, that's the 7 minutes. I hope that helps a bit more on understanding it. There is this podcast. Let me open this podcast. Okay, it's only 4 minutes. It's only 4 minutes. Let's do this. How are we going to do this? Is I'm going to highlight which part that this lady is talking about in this keynote. So let's start now. Yes, something to think about. So by now, I think you have a good idea that what are these 4 drawers about. Now, we will do a test. We'll do a quick test. Let me just pull this out. We'll do a quick test. ChatGPT, we will upload the textbook for this chapter, Force and Motion. And it's about 40 pages. 40 pages, and we will ask ChatGPT to create 10 MCQ questions. Ask one by one. All right. And let's see how many questions we can answer it correctly. Right. So we'll do this very quickly, but I need some response from the team quickly also. How are we going to do this is you read the question, you tell me which drawer. Okay, before that, let me just show this here, the drawing. Okay, imagine now you are in the exam hall with the drawing only with you. You cannot bring all your notes in with your in the exam hall. So with the drawing next to you, and let's see if the drawing is able to help you to remember the answers. Okay, let's start number 1. Which drawer is this? And then tell me what's the answer. Can we start with Aiden? Aiden, which drawer? 1, 2, 3, or 4? And what is the answer? A, B, C, or D?
The drawer is number 1, and 12 newtons to the right and 5 newtons to the left. What is the resultant force on the box? It is 7, right? 7 newtons to the right. So it's A.
It's A. Okay, so drawer number 1 is correct. Let's
Yes.
see what's the answer. Yes, that's correct. Right? Give me the questions 2 at a time. Okay, so we have 2 questions. Right? So Ding Sum, you do question number 2. Xingling do question number 3. Tell me which drawer and which answer, A, B, C, or D. You can type if you want. Which drawer, which answer? Which drawer, Ding Sum? The answer is wrong, it's okay. Okay, don't worry. Xingling, don't worry. Also, Yenta, don't worry. And Ding Sum, don't worry. We just need to go through this quickly and know how to do this. What is the drill that we are doing now? Okay. Okay, Ding Sum, let's do Ding Sum. Ding Sum, drawer 2, answer B. Okay. Anyone reject the answer? So 2 is B. And let's see. Question 3, answer is A. What is the drawer? Do you know? Xingling? Anyone did not agree on the answer? Then just raise your hand or tell me. 2B, 3A. Xingling, which drawer? Quickly. We are running out of time. We actually exceeded the time actually. Okay, I'll tell you the answer is drawer number 1. Okay, this part here. This part here. Constant velocity. Right? Drawer number 1. Okay, it's fine. Okay, so far so good. Question number 4, Yunta. Question number 5, Aiden. Let's do that. Drawer, answer. Yunta, number 4. Number 5, Aiden.
Do I go now?
Hmm?
Can I answer number 5 right now?
Yeah, please, please.
Number 5, force of equilibrium is drawer number 4, and the the answer would be C, where the resultant force will equal to 0, because it's
Okay.
balanced.
Is it drawer number 3 or number 4?
Number 4.
Equilibrium
For
is
number
number
5,
4?
no, number 3. Oops, I read
Yes,
wrong.
number 3.
Number 3.
Yeah, yeah. That's right. Yunta, drawer number 2, and the answer. The answer, yeah, answer you need to do the calculation. You need to do the calculation. Forces. So the answer is horizontal. Horizontal is cos. So 20 cos 30. I don't know why it's cos 30. Let's say if it is B, then it's B. Right, but the formula is this one, using this one, okay? 20 times cos 30 degree. Right, there's this, you have to convert this cos 30 degree is equivalent to what? 0 point something or what? Okay, let's see the answer. Because we are running out of time, I also have another class in 15 minutes. Excellent, Yenta. I think you did a very good job. Hurry up, hurry up. Yeah, 20 cos 30, right? Okay. So far, so good. Okay, number 6. Whose turn is this? Jingsam and Xingling. Jingsam, number 6. Xingling, number 7. Drawer, answer. Which drawer? Which answer? Jingsam, answer is A. Which drawer? We have time. Jingsam, which drawer? Just give a guess. It's either one of the 4. 1, 2, 3, 4. Xingling is typing. Let's wait. Yes, drawer number 2. Yes, you're right. Because you have to separate them, right? You split them into horizontal or parallel. Drawer 4, answer A. Yes, drawer 4, answer. Anyone reject? Anyone object? Okay, no one. Let's try. Oh, superb. So far, so good. Okay, last two. Who wants to answer? The fastest get the answer. Right? Drawer, tell me the drawer, tell me the answer. You can type, you can speak it out. Let's try. Come on. Two more. Then we have one more coming. Number 8. Hurry up, hurry up. Aiden.
Yes. Yes.
Yes. Draw answer. Try. If you're ready.
Which one? Question, which question?
Either one. Or anyone.
Mm.
It's okay.
Three forces
When you're
acting
ready,
on an
you can speak
object
up.
are in equilibrium. What condition must be true? Two forces must be equal. I don't know the answers for number 9 or 8.
You don't know the answer?
No, I
Okay.
don't.
Anyone else? Try. Anyone else? Hurry up. Question number, at least you know the drawer, Aiden, right? Question number 8 and question number 9.
Yes, I
Which
know it.
drawer?
Yeah, I know the drawers. The drawers for question 8 is drawer number 4. Question number 9 is for drawer number 3.
Excellent. Okay, so for question number 9, okay, for signaling answer, number 8 is drawer number 4. Okay, answer is A. Is that the answer that signaling you want? And now number 9. No, I think you are typing something. All right. And number 9 is drawer number 4. Number 9 is drawer number 3. Number 9 is B. Number 8 is what? Are you answering number 8 or number 9? Okay, number 9. So who can answer number 8? Or Sydney, you can also answer number 8 if you have the answer. Anyone? Yenta, Jingsam. Just try. We already have the drawer. Drawer number 3. Drawer number 4, sorry. Question 8, drawer number 4. So what's the answer? Don't be shy. D? Anyone object? No one? Let's try. Okay, so we have one wrong, but it's fine. Wrong is fine. So you have new information, then you store it into your drawer number 4. Okay, this is the formula. Okay, now I think you know the answer. Okay, last one. Which drawer, which answer? Hurry up. So far, everyone is doing well. Don't worry. Newton's second law. Which drawer? Let's start with which drawer first. Anyone can tell me which drawer? Newton's second law. Remember this drawing? Which one is the Newton's second law? Come on. Yes, drawer number 1. Yes, Sailing, you're right. New mummy. Okay, new mummy. Newton's second law. Now, which drawer? Which answer? What is the resultant force acting on it? Second law is what? F equivalent to MA. Oh, you have B. Okay. F equivalent to MA. B. Anyone object? That's right. Perfect. Okay, so we got 9 out of 10. These are not difficult questions. I have to admit, these are easy questions. Not as easy as 1+1. Okay, if anyone did not go through these 2.5 hours with us, he will not, or she will not be able to get 9 out of 10 for sure. And we only take 2.5 hours, and now you have a good understanding of the chapter, right? So I think you should be quite proud of yourself. And I hope you learned something from here, right? Uh, I'm going to organize next week a revision class for this chapter. A revision class for this chapter. And what is this revision class? Is to teach you again the steps of how to do revision in a very fast way. In less than 10 minutes, you can do a revision already. Okay, but I have to teach you the method. I have to use about 1 to 2 hours to teach you the method for you to understand how to do this revision quickly by yourself. Okay, I hope this class is useful for you. And if you find it useful and you want to learn more about this revision method, stay tuned next week. I'm going to send you the link. Right. This is my let me give you my number. This is my number. For those that do not have my number yet, +966 592441513. This is my number. Jot down quickly and drop me a WhatsApp message and tell me who you are, your name. Then we will stay in touch. I can send you the link. Right. Okay. Again, I hope you are learning something from here. And I hope to see you next week. And thank you very much, all the students here. Thank you so much. And bye-bye.
Bye bye.
Bye-bye.